Hari Om to everyone. Today in this session we are going to discuss about what is going to happen when the dielectric is inserted in a capacitor. Now we know that capacitor is a device to store electric energy, okay, which has a relation C is equal to Q by V, where C is a capacitance and V is a potential and Q is a charge. Okay. Now in this case I am going to tell you that we are going to discuss two cases. What may happen when the battery disconnected after charging the capacitor, then inserted the dielectric, and the second case, the battery remains connected and the dielectric is inserted. These two things we are going to discuss. Okay, see, let me go to the session. The effect of dielectrics in a capacitor. So before we are going to explain, you just look at the diagram. Actually, this is a diagram, a microscopic view of the sprinkles of iron filings, okay, especially when the plates will be connected between the electric field. Okay, so look at, we could find one thing, we can have the arrangements of filings in between the plates, not outside the plates. This will indicate the electric field will be generated in between the plates, especially when this is positive and this is negative, where E will be equal to sigma by epsilon naught. And what is sigma? Sigma is a surface charge density. Okay, right. Now, so when the space between the capacitor is filled with dielectric instead of air, the capacitance is definitely altered. How it is altered? Okay, so there are two possibilities when the capacitor is disconnected from the battery and the capacitor is connected to the battery. Okay, right. This is the first case. When I first charging the capacitor, then I will disconnect the battery. What is going to happen? Okay, look here. Now the capacitance of the dielectric is C is equal to epsilon Q naught by V naught. Then when the battery is disconnected, then the new electric field will be E is equal to E naught by V naught. Why? Because we know that epsilon R is equal to epsilon divided by epsilon naught. So F will be equal to F naught divided by epsilon R. Simultaneously, E will be equal to E naught by epsilon R. So from this I will come to know E is less than E naught. Why? Because epsilon R is greater than 1. Okay, so this is what they have given. When the epsilon R is greater than 1, the E will be less than E naught. So what is its meaning? So E naught is an electric field in air and E is an electric field in dielectric. Okay, right. Now, so as a result, the electric potential between the plates is decreased. When the according to the relation C is equal to Q by V, when the potential decrease, capacitance will be increased. Okay, so moreover Q naught remains constant. Okay, so V will become V naught by epsilon R. Okay, now this is the thing I would like to tell you. Now look at, so the new capacitance of the capacitor will be C is equal to Q naught by V. V is equal to, instead of V I have to substitute V is equal to V naught by epsilon R. So when I substitute this in this equation, I will get C is equal to epsilon R into C naught, or epsilon R is equal to C divided by C naught. Okay, right. Now see, so from this is the elaborate explanation about the what is going to happen for the energy. So this is a important relation, C is equal to epsilon naught A by D, that is C naught is equal to epsilon naught A by D. So C is equal to epsilon R into epsilon naught into A by D. Okay, so when I substitute U naught is equal to 1 by 2 Q naught square by C naught, then I will get U is equal to this one. So from this I will come to know U is less than U naught. Okay. Then since epsilon R is greater than 1, U is less than 1. We have already discussed. So what is the thing? There is a decrease in energy because when the dielectric is inserted, the capacitor spends some energy to pulling the dielectric inside. Now the battery remains connected. the potential difference V naught across is going to constant. Why? Because the battery will be connected parallel to it. So when the dielectric is inserted, the charge of the capacitor will be increased. How much this will be increased? Q will be equal to epsilon R times Q naught, where Q naught is a charge when it is being in a air. Okay, so when Q is equal to this is what the circuit, right? Now look here. So C will be equal to epsilon R into C naught, and C naught is equal to epsilon naught A by D. Okay, and C is equal to epsilon naught A by D. Now I am going to use the new formula, that is U is equal to 1 by 2 CV square. Okay, so now when I substitute the value of E naught, okay, and finally we just have, okay, U is equal to 1 by 2, okay, wait, yeah, U is equal to 1 by 2 CV square when it is placed in a dielectric, and V is going to keep constant, and C will be equal to epsilon R into C naught. So when I substitute, U will be equal to 1 by 2 epsilon R into C naught into V squared. Okay, now I know that 1 by 2 C naught into V squared is equal to U naught. So U is equal to epsilon R times U naught. So from this I will come to know U is greater than U naught, where when the battery remains connected. Okay, so this is the thing we will come to know. Okay, actually this is what the principle we are using in the computer keyboard. So when you are in your computer key, okay, when it is placed, the separation between the plates decreases, leading to increase the capacitance. Okay, this trigger electronic circuits to identify which key has pressed, and this is the short form. Okay, so we can come to know what will happen when the dielectric is inserted. When the battery disconnected, the charge is kept constant, the voltage decrease, and the energy decrease, and the electric field decrease. Only the capacitance increase. Now when the battery is connected, the charge increase, okay, the capacitance increase, energy increase, but the voltage and the electric field is kept constant. Okay, thank you.